For 6 weeks in the fall of 2025, the United States government went dark, and so did NASA's public communications, right in the middle of the most important observation window for the strangest object the agency had tracked in years. In that silence, a rumor took hold that the object speeding through our solar system might not be a comet at all. It might be a spacecraft. When NASA finally spoke again, the answer they gave was not the one either side of that argument expected. And it took the scientific community the better part of a year to fully back it up with evidence. The object is real, it is natural, and it is old in a way that very few things in the observable universe are old. Not thousands of years, not millions. Quite possibly billions of years older than the sun. Itself, a scale of time that is genuinely difficult to hold in your head next to anything human. This is the story of how a government shutdown turned an interstellar comet into an internet mystery, and how the actual confirmed answer, pieced together over the months since, turned out to be stranger than the conspiracy theory it replaced. It is also a useful case study in what happens when real uncertainty, the ordinary, unglamorous kind that comes from data taking months to process, gets mistaken for deliberate concealment simply because nobody was around to explain the difference. Start with the basic facts, because they are worth having straight before the rumor enters the picture. On July 1st, 2025, the NASA-funded Atlas Survey Telescope in Rio Hurtado, Chile, part of a network originally built to spot asteroids that might threaten Earth, detected a faint object moving on a trajectory too extreme to be anything native to our solar system. Most objects orbiting the sun trace closed ellipses, loops that bring them back around again and again over years or centuries. This one was moving too fast for the sun's gravity to ever capture it, on a hyperbolic path that meant it had arrived from somewhere else entirely and would leave again permanently once its brief visit was over. This made it only the third confirmed interstellar object in human history, after Oumuamua in 2017 and Borisov in 2019, and astronomers named it 3I Atlas, the 3 marking its place in that short list, Atlas, crediting the telescope that found it. It was moving at roughly 137,000 miles an hour when discovered, faster than either of the 2 interstellar objects that came before it, and its orbit was more extreme, more sharply hyperbolic, than anything ever recorded passing this close to the sun. For the first 3 months after discovery, the story unfolded the way these things normally do. Telescopes around the world tracked the comet as it approached the inner solar system. Hubble captured images of a dust, plume streaming off its sunlit side. The James Webb Space Telescope detected carbon dioxide, water, and carbon monoxide boiling off its surface as sunlight warmed the ice. Astronomers planned a coordinated observation campaign involving more than 20 different NASA missions and orbiters, timed around the comet's closest approach to the sun in late October. Spacecraft never designed with comet hunting in mind were repurposed for the effort. The European Space Agency turned its Mars Express orbiter, its ExoMars Trace Gas orbiter, and the Jupiter-bound JUICE spacecraft toward the object, gathering whatever images and spectra their instruments could manage from millions of miles away. NASA's Perseverance rover, sitting on the surface of Mars, even caught a faint streak of the comet crossing its navigation camera's field of view during a routine 10-minute exposure sequence, an image that would later be misread online as a solid artificial object rather than what it actually was. The comet's light stacked across hundreds of individual frames. Every one of these observations depended on coordination through NASA's public communication channels, the same channels that were about to go dark. Then on October 1st, 2025, the United States government shut down, and it stayed shut down for 43 days, the second longest shutdown in the country's history. NASA's public affairs offices went dark. Routine updates on the comet's position stopped appearing. The agency's near-Earth object database experienced intermittent outages. Images already captured by spacecraft like the Mars Reconnaissance Orbiter, which had caught 3I Atlas passing within about 18 million miles of Mars in early October, sat unreleased, waiting on the other side of a bureaucratic freeze that had nothing to do with the comet itself. The timing could not have been worse. The shutdown fell across exactly the window when 3I Atlas was making its closest approach to the Sun and to Mars, the period when the most valuable, highest resolution data was being collected. And because the comet's perihelion happened to occur on the far side of the Sun as seen from Earth, ground-based telescopes were already struggling to observe it directly, making the spacecraft-based observations, the exact data now stuck behind government offices with their lights off, more critical than usual rather than less. The spacecraft data that could have filled that gap was the exact data now stuck behind a closed government office. Into that vacuum stepped a chorus of speculation, led most visibly by Harvard astrophysicist Avi Loeb, who had previously drawn attention for suggesting the very first interstellar object, Oumuamua, might have been artificial. Loeb argued that 3I Atlas's orbital plane sat unusually close to the plane in which the planets orbit the Sun, a Coincidence he calculated as extremely unlikely by chance, roughly a fraction of a percent, and pointed to unusual jet structures in its coma and a measurable non-gravitational acceleration in its path as reasons to take an artificial origin seriously. Loeb was careful, in his own writing, to frame these as open questions worth investigating rather than settled conclusions. But the nuance of that framing did not survive contact with social media, where a hedge about probability is easily flattened into a headline stripped of its uncertainty. He publicly accused NASA of sitting on high-resolution images captured by the Mars orbiter's HiRISE camera. Images, he said, were sharper than anything released to the public, and suggested the shutdown was being used as a convenient excuse for a deliberate delay. Members of Congress began asking questions, including requests directed at NASA specifically about the withheld imagery. Elon Musk raised the topic on a widely watched podcast. Social media filled with talk of alien motherships and government cover-ups, amplified by the fact that, technically, several of Loeb's individual observations were accurate. The images genuinely had not been released. The orbital alignment genuinely was statistically unusual. What got lost was the distinction between an unusual data point and evidence of anything artificial, a distinction that is easy to lose when the people best equipped to explain it are legally barred from speaking publicly. By the time the shutdown ended on November 12, 2025, a genuine, widely shared narrative had formed that NASA was hiding something. When the shutdown ended, NASA did not stay quiet for long. Within about 2 weeks, the agency held a televised briefing, bringing together observations and early analysis from more than 20 missions across the solar system into the most complete public picture of 3I Atlas assembled up to that point. NASA Associate Administrator Amit Kshatriya addressed the alien speculation directly and, without hedging, stating plainly that the object was of natural origin. Nikki Fox, the Associate Administrator of NASA's Science Mission Directorate, went further, saying that none of the observations gathered across the entire fleet of spacecraft that had been tracking the comet showed anything resembling a technosignature or any evidence at all that it was anything other than a comet. The unusual jet structures, the orbital geometry, the acceleration Loeb had flagged as anomalous, all of it, according to the scientists who had actually gathered and analyzed the data, was consistent with ordinary cometary outgassing and rotation. The delay in releasing the HiRISE images, NASA confirmed, was exactly what it appeared to be, a bureaucratic side effect of the shutdown rather than a deliberate act of concealment, and the images were released not long after. That briefing settled the question of what 3I Atlas is not. It is not a spacecraft. It is not artificial. It carries no detectable technology and no signal. The specific anomalies Loeb had flagged turned out to have ordinary explanations once the full dataset was available rather than fragments of it. The non-gravitational acceleration, the small extra push on the comet's trajectory beyond what the sun's gravity alone would produce, is a well-understood effect in ordinary comets, caused by jets of gas venting unevenly off a rotating, irregularly shaped nucleus as it warms, acting like a very weak, lopsided rocket thruster made of escaping ice. Every comet in our own solar system shows some version of this effect, and 3I Atlas's version, once modeled properly, fell within the expected range for an active, outgassing nucleus of its estimated size. The orbital alignment Loeb had calculated as improbable remained statistically true but stopped being treated as meaningful, since a genuinely random population of interstellar objects passing through the solar system would still be expected to produce the occasional unusual-looking coincidence purely by chance, especially from a sample size of only 3 confirmed objects ever observed. But it left open, and arguably made more interesting, the question of what 3I Atlas actually is, and that is the question the science community has spent the months since methodically answering. This is where the real confirmed origin story begins, and it did not come from a single announcement. It came from several independent research teams using different telescopes and different techniques, converging on the same conclusion from different directions. The first major piece came from the James Webb Space Telescope. As 3I Atlas moved away from the Sun in December 2025, freshly warmed and actively venting gas from its recent close pass, a team led by astrochemist Martin Cordner at NASA's Goddard Space Flight Center used Webb's near-infrared spectrograph to measure the precise chemical fingerprint of the gas escaping the comet's surface. What they found was a level of deuterium, a heavier form of hydrogen, sometimes called heavy water when bound into ice, roughly 30 times higher than what is typically found in comets native to our own solar system. That kind of enrichment happens only when ice forms in an extremely cold environment and is never significantly warmed afterward, meaning 3I Atlas spent its formative years locked in a deep freeze far colder than anything comets in our own solar system experienced. The same measurements showed unusually low levels of carbon-13 relative to ordinary carbon-12, a ratio that builds up gradually in the galaxy over successive generations of stars living and dying. A low ratio points toward an origin very early in the galaxy's chemical history, before many generations of stars had lived and died to enrich the surrounding gas. Based on these measurements, Cordner's team estimated that 3I Atlas could have formed as long as 10 to 12 billion years, ago, during a period astronomers call the universe's cosmic noon, when star formation across the galaxy was at its most intense. A second independent study, led by astronomer Cyrielle Opatom at the University of Edinburgh, using the European Southern Observatory's Very Large Telescope, arrived at a compatible conclusion using an entirely different chemical signature. Opatom's team measured unusually high ratios of carbon and nitrogen isotopes in the comet's coma, a pattern that, combined with modeling of how such ratios build up around different types of stars, pointed to formation in the outskirts of an old low metallicity star system, a star with very few elements heavier than helium in its makeup, the kind of star that forms only during the universe's earliest chemically undeveloped eras, long before generations of stellar death had enriched the surrounding gas with heavier elements. Researchers involved in that study estimated 3I Atlas could be more than twice the age of our own sun, possibly exceeding 9 billion years old, a figure that, on its own, would already have made global headlines even without the shutdown-fueled controversy surrounding it. A third analysis, modeling the comet's motion backward through the galaxy's rotation to estimate how long it must have been drifting. To arrive at its current trajectory, placed its likely age somewhere between 3 and 11 billion years, consistent with an origin in the galaxy's thick disk, an older, more chaotically orbiting population of stars than the flat, orderly disk our own sun belongs to, a population that formed early enough in the galaxy's history that its member stars now trace paths tilted well away from the plane. Most younger stars, including the sun, settle into overtime. 3 separate teams, 3 separate methods, chemistry from 2 different telescopes, and orbital dynamics modeled independently, all converging on the same basic picture. 3I Atlas is not simply old. It is very plausibly the oldest confirmed object ever to pass through our solar system, a physical fragment of a planetary system that existed and very possibly finished its entire life cycle before our own sun had even formed. To understand why scientists trust chemistry to reveal something's age this precisely, it helps to think of a comet the way a geologist thinks of a tree ring or an ice core. A ring inside a tree trunk records the exact conditions of the single year it grew in, sealed away and essentially unchanged by everything that happened afterward. A comet's ice works the same way, except instead of recording a single year, it can record the chemical conditions of the entire environment it formed in. And unlike a tree, a comet spends nearly all of its existence in deep, cold storage, far from any heat source that would blur or erase that original signature. When 3I Atlas finally warmed up near the sun for the first and only time in its multi-billion-year existence, it was releasing a chemical record that had been sealed since before our solar system existed, and 3 different teams, using 3 different instruments, all read that record the same way. That is the true origin NASA and the wider research community have now confirmed, not through a single dramatic press release, but through months of patient, cross-checked, peer-reviewed analysis that built steadily on the foundation laid by the first November briefing, refined further with each new paper as more telescope time became available. It is worth sitting with the contrast between the story that spread during the shutdown and the story that has actually been confirmed since. The rumor promised something almost comfortingly simple, a hidden truth that a government agency was suppressing, a single dramatic reveal waiting behind a locked door. The real answer took months to assemble, required 3 independent research groups working with different instruments on different continents, and arrived not as a secret finally released, but as a careful scientific consensus built in full public view, published in peer-reviewed journals that anyone can read. And the actual finding is, if anything, more remarkable than the rumor it replaced. Nobody needed to imagine an alien spacecraft to find something extraordinary here. A team of astronomers pointed some of the most sophisticated instruments ever built at a fragment of ice drifting past our solar system, and confirmed that it carries a chemical record of the galaxy from a period before our sun existed, a genuine, verifiable message from deep time delivered by nothing more exotic than physics and coincidence. There is also a broader lesson here about how these rumors take hold in the first place, one that has nothing to do with aliens at all. Science does not move at the speed of a news cycle. Processing spectroscopic data, cross-checking isotope ratios against galactic chemical evolution models, and getting a finding through peer review is a process that reliably takes months, sometimes longer, regardless of how badly the public wants an answer immediately. Under ordinary circumstances, that lag is simply background noise, an unremarkable fact of how research works. But layer a 6-week communications blackout on top of it, at the exact moment public curiosity is at its peak, and that same ordinary lag starts to look, to an anxious and undersupplied audience, like evidence of something being hidden. The shutdown did not create the rumor out of nothing. It created the silence that the rumor needed in order to grow. And once NASA's channels came back online, filling that silence with real, verifiable science took considerably longer than the rumor had taken to spread in the first place. That asymmetry, a false claim spreading in days while its correction takes months, is not unique to this story, but 3I Atlas may be one of the cleanest, best documented examples of it in recent scientific history, precisely because so much of the timeline, the shutdown dates, the briefing transcripts, the publication dates of each peer-reviewed paper, is a matter of public record that anyone curious enough to check can verify for themselves. 3I's Atlas is already leaving. It passed its closest approach to the Sun in October of 2025, sped past Jupiter's orbit in the spring of 2026, and is now accelerating back out toward interstellar space on a trajectory that guarantees it will never return. Not in any timescale that means anything to a human civilization. Every telescope currently pointed at it is working against a closing window because within another year or so it will fade beyond the reach of even the most powerful instruments on Earth. What it leaves behind is not a secret NASA kept from anyone, but a rare, hard-won, thoroughly confirmed piece of evidence about a period in the universe's history that no telescope on Earth, however powerful, could otherwise have reached. The truth, once you actually wait for it, has a way of turning out larger than the rumor that filled the silence while everyone was waiting to hear it.